This video will deal with some of the mathematical manipulations we're going to do with the mole. Okay, mole to mass, mole to volume, and then some of the volume to mass type of conversions using the mole. So first I'm going to do is how to get from grams to moles, okay, using the example problem that's on the screen now, and that I also have written on the board. So how do you solve these ones? First step you need is the molar mass, because if you're trying to go from moles to mass, the relationship is the molar mass. You need to know how much 1 mole weighs to figure out what proportion of the mole you have weighs. So to find the molar mass of potassium nitrate, for example, you add up the mass of potassium and of nitrate and of 3 oxygens from your periodic table. And when I do that, I get that the molar mass of potassium nitrate is 101.102 grams per mole. Okay, so the molar mass is always how many grams it is per mole. So now to use it in this problem, every single conversion problem we do, we're going to use conversion factors. The unit we start with comes down onto the bottom. Okay, the unit we want to convert into goes on top. And then you ask yourself, what's the relationship? And for a mole to mass relationship, the relationship is molar mass. I have 101.102 grams per mole. So I have 101.102 grams for every 1 mole. Multiply this through to get a final answer, and you should get a final answer of 0.349 grams of KNO3. 3 sig figs to start, 3 sig figs to end. If we had another problem like this one on the bottom, where you're going from grams to mole instead of from mole to grams, the difference here would be, if I set this up, magnesium chlorate, okay, multiply, draw your line. This time, the unit you're starting with is grams of magnesium chlorate, and you're converting that into moles of magnesium chlorate. So this time, the conversion factor is flipped. The mass you get from your periodic table would be in the denominator instead of the numerator. Okay? That's the difference for this particular problem. There's another conversion we can do, and that's moles to volume. Okay? We have a mole to particle relationship, and that is that 1 mole equals 6.02 times 10 to the 23rd particles. We have a mole to gram relationship, and that is that it varies per particle, but it's the mass from the periodic table. Our mole to volume relationship is this one that's on the screen. So at a standard temperature and pressure, the mole amount relates to the volume of a gas, and that is for every 1 mole, you're going to have 22.4 liters of any gas, any, regardless of mass of the individual particles. This is at standard temperature and pressure, which is STP. Okay, that's how it's abbreviated, STP. Standard temperature and pressure are usually considered room conditions. So this is something we'll talk about next unit in terms of what it actually means. Okay, but they're a standard temperature and pressure that we use to talk about gases. So let's do this problem on the screen. How many moles are there if you have 5,500 milliliters of carbon monoxide gas? So here's what you start with. Multiply, draw your line. The unit you have here comes down. And now this is going to be a multi-step conversion. The reason is, if we're trying to get to the mole, we don't have a relationship of mole to milliliter. We have a relationship of 1 mole equaling 22.4 liters. So we need to get this to liters first, which you can do using conversion factors. For every 1 liter, I have 1,000 milliliters. So those cancel. Now I have liters of carbon monoxide coming down, and I have mole on top. For every 1 mole, I have 22.4 liters. Now I have my answer, my final unit. You're going to multiply this through. 5,500 times 1 divided by 1,000 times 1 divided by 22.4. It should get you a final answer of 0.25 moles of CO, 2 sig figs, 2 sig figs. The last thing you're going to be able to do with the mole is bring all of these together. If you notice, our mole to counting, our mole to volume, and our mole to mass calculations all use the mole. So if you can figure out how many moles you have of any measurement, you can convert to another type of measurement through the mole. Because if you have 2 moles of like oxygen gas, for example, you can figure out the mass of that oxygen gas, you can figure out the volume of that oxygen gas, and you can figure out how many particles there are of that oxygen gas. So the mole is very powerful for this reason, and that from the mole, we can do anything we want numerically in terms of measurement. So here's what we oftentimes call a mole map or a road map, and it shows you how from the mole you can get to any of these 3 calculations. So really you have 3 conversion factors for this start of the unit. We have the Avogadro number conversion factor, we have the molar mass conversion factor, and we have the volume conversion factor with 22.4. You just have to know which one to use when, and also to realize that in some problems you might need more than one. How will you know if you need more than one or not? Well, if your final answer is not in mole, and your starting quantity is not in mole, you're going to be doing 2 conversions, because the mole is always something we will be using to convert to or from. So here's a couple examples of potential problems that take it one step further, asking you to use more than one conversion factor. I'm going to do the first one and then the last one for sure. First one, how many molecules are there in 35.7 grams of nitrogen? Number 1 is to write a chemical formula for nitrogen, and nitrogen's a diatomic, so that's N2. In this problem, you see I'm going from grams to molecules. So I notice right away I don't have mole as either my starting or my ending. And what that means is I have to convert to the mole to convert to a new type of measurement. Okay, my mole is always my transition point, and you're going to find this is very consistent. Your mole is always what you're going to convert to use it as your relating factor. So for this problem, I can set it up just with units without any numbers even. I'm going to start out with grams of nitrogen, and I'm going to convert that to moles of nitrogen, because I always have to go through the mole to get to a new quantity. And then I'm going to go from the mole to molecules. In the end then, if I do this right, my final answer will be in molecules. Now it's just a question of filling in the right numbers. Gram to mole relationship is the molar mass relationship. To get those numbers, you need to use your periodic table. Mole to molecule relationship right here is your Avogadro's number relationship. For every 1 mole, I have 6.02 times 10 to the 23rd molecules. This is from your periodic table. For every 1 mole, I have the molar mass of nitrogen, which if you calculate it, you'll see it ends up being 28.014. You multiply this through now, 35.7 divided by 28.04, multiplied by 6.02 times 10 to the 23rd. You should get a final answer of 7.67 times 10 to the 23rd molecules of N2. Okay. So this is using the mole to convert from counting to mass, which is similar to what we did as an interactivity to the mole. The last problem on here asks you to go from grams to milliliter, and sometimes I note down where I want to end just as a reminder to myself. And again, I can set this whole thing up without numbers. Starting in grams of O2, I have to go to mole because that's my only relationship from gram. The mole is how we relate. From that, I know I want to go to volume eventually, so I'm going to go from moles of O2 to volume. And the only relationship I have so far is liters. And once I'm in liters of O2, I can get to milliliters just using what I already know about my relationships between prefixes. So for every 1 unit liter, that's 1,000 milliliters. For every 1 mole, that's 22.4 liters. This number you'd have to calculate using your periodic table. 2 oxygens add up to be 31.98 grams. 45 times 1 divided by 31.98 times 22.4 divided by 1 times 1,000 gets me a final answer of 2 sig figs. Oh, is it 2? It's 3 sig figs. 3 sig figs, 31,500 milliliters. This is as hard as it really gets for these types of problems. Have a nice night.